Howdy, everybody. Hope you're doing well whenever you are. We're here for day 25 of Advent of Code. Um, it's the last day. It's been a fun month for me. I am getting it done, but I'm getting it done late. I finished day 25 just this afternoon or today sometime in the morning. It turned out not to be too hard of a problem, and that is not uncommon for Advent of Code. I think they kind of realize, oh, we should stay 25. Some of these people are probably doing it before opening Christmas presents or in between, whatever. And so most day 25s, at least that I remember, only actually have one problem, and then you get the last star for free. Like there's only one part to it, and they're usually not too hard, at least from the days that I remember. So this day will actually not be too hard because the solution is actually fairly simple. Um, but let's get into it. Day 25, we're finally done. We finished it off. Hopefully, you've been able to follow along. I'd love to see if you have a GitHub repo with all of your solutions. I'd love to review them and look them over, even if it's a language I'm not familiar with. Right? There's some of them that I just can't grok at all, and I won't be able to be of much help. But I'd love to look and figure them out and go through them because I plan to do some recaps of like days and some rewrites of days based on input and stuff like that. So let me know where yours is. So with that, let's start at day 25. It's called Code Chronicle. Essentially, you've done all this work to go find this historian all over the place. And then you ask yourself, I wonder if he's just back in his office. We've gone through all this searching. We've searched everywhere. Maybe he's just back in his office. And so you go look and you find the office is locked, but you hear someone inside. And so you're like, oh, we got to open up this lock somehow to see if it's him in there. And so they come back with a bunch of keys and but they don't know which key goes to this lock. And not only that, but all the locks on all the keys aren't specific to that specific lock. It's their keys that could fit any lock on that floor. So the way to think about it is you've got a bunch of locks and a bunch of keys, and you're trying to figure out, at least initially my thought was, oh, am I just trying to figure out which one fits this one? What they actually want you to do is say, you've got a bunch of locks and you've got a bunch of keys. Can you figure out how many keys fit in a lock? And so you can see here by the outputs, even though this is the same lock, two keys fit in, right? Meaning they would go in, they would fit in the lock. What in the real world, this shouldn't happen. I guess there's skeleton keys that kind of work this way, but generally speaking, is like one lock to one key, even though there's only a few tumblers. But they're going to give you some input or some input that looks like this. Anything that's going down is a lock. So this is a lock and this is a lock. And anything is going up is a key, right? And the idea, if you've ever seen how a lock works or a key looks, I don't want to, for some reason I was like, I should just show you my key. But if I show you my key, you'll know what my key looks like. Not that you necessarily know what I live, but where I live. But anyway, the point is the keys have kind of ridges. And so this represents the ridges of the key, and then this represents the ridges of a lock. And the question is like, will they fit? That's all it's asking is like, will it fit? Not if it's an exact fit, right? Like the exact fit of this lock would like fill these dots, right? It's not even asking that. It's just saying which of these keys could be inserted into this lock. And you can kind of think about it as like if you overlay the two, you have a lock and a key. If you overlay the two, do any of their lines like meet up and hit each other? Like if they ever meet up and hit each other, that's where they're bad. And that's literally all it's asking, right? It describes this in more details. It's like you can turn this lock into these set of numbers. And you can turn this key into this set of numbers. And then the question is, will these numbers fit in here? Like essentially it's asking, is it less than or equal to those values? And it just wants you to find how many of them overlap, right? So this actually didn't seem like a hard problem. I was like, well, maybe there's a lot of them. And I don't think there's actually a ton of them. Where's my input? Here. I mean, there are a relatively quite a few of them. Like if you look at this, I'm scrolling for a while, but there's only like a couple thousand. And so you can imagine the case where like you have a couple thousand locks, or sorry, 1,000 keys and 1,000 locks. How many keys do those all fit? How many times does a key fit into a lock? You're only doing like 1,000 times 1,000, which at worst case is 1,000,000, and you're only comparing numbers. So that led me to believe I'm just going to try and brute force it. Not only am I going to try and brute force it, I'm just going to literally just like check all the values, and I'm going to do it in a very like functional way, so you can see it's very functional. So here's my solution. Again, today is not hard at all. I don't imagine there's any trick to it. I would be interested to see if someone has a trick. But basically what I'm going to do is I'm just going to take the input, and here's my super functional way of doing it. I'm going to split by double new line. So that's going to give me like the split right here. Why does VS Code do that? It's going to give me the split like right here. And then for each of those, so now I've got like a block of these. I'm just going to figure out, is it a lock or is it a key? And I'm just going to gather the heights of those of the lock or the key, right? And it turns out the function works the same for both of them. It doesn't take much to figure out how to do that. But how do I know whether it's a lock or a key? Well, if the first character is a hash, I know it's a lock, and that's it. Basically, the problem just says that. So I really just look those up. If it's a lock, I add it to the lock list. If it's a key, I add it to the key list. And so now I have some locks and keys. So what does the height function look like? Here's my super functional way of doing it. Again, I try to do this all very functional programming. What does my height function do? Basically, I go through all the lines, and then I go through all the characters, enumerating them, and then I just fill up the columns for all the hashes, right? Any place I see a hash, a hashtag, I can say I'm going to fold those hashes by their column, right? I'm going to increment each column by 1. So what does this have the effect of doing? Is essentially when I see a hash here, I know I'm in column 0 because I've enumerated it. So I just add 1 to column 0. Then I add 1 to column 1 right here, and 1 to column 4 and 5. And then this one, I only add it to column 2 and 4 and 5, and then only 4 and 5, and then only 4, only 4. So as I'm going through these, I'm basically just adding hashes to these. Notice I start with a -1. That's just because all of the locks have a hash at the top, and all the keys have a hash at the bottom. And the problem is specifically ignoring those, right? So if you look at what the problem is saying when it shows you an example, right here, it says that this one, the first column is a 0. And so you can see it's clearly ignoring like this part of it, and it's only counting from right here down. And so it's completely empty, but this one has 5 of the 6 filled in. So that's why I'm starting with the -1. But again, so I basically just go through all the lines, enumerate all the characters, filter only by, I'm only interested in the hashes, and then I start at -1. Admittedly, I could probably skip a line, and this would probably, it's risky to do this live, right? That won't work for, I was going to say, can I just skip this first one? But down here, I actually want to skip the last one. Like if it's a key, I only want to skip this last one, not this one right here. So anyway, that I can't do that. Really, this is a very concise way, I guess, of doing both of them at the same time. I'll have to think about if you could make it more concise. But anyway, so now I have my locks and my keys. And so I'm literally just going to, for each of my locks, I'm going to iterate over them, and I'm going to count how many times I find a key that fits in it. And I'm just going to get a count of those, and then I'm going to sum them up. Okay. I wonder if I could use the Cartesian product, and that would give me the same answer. We'll try that in a second. I didn't even use itertools for this because I could just literally do a map of each of them. And it wasn't fast. I thought, oh, is there a bunch? And I can use like Rayon to speed it up and stuff like that. But it's really just, I mean, I didn't even time it because it happened so fast. Usually when it's like kind of slow, I add the timer so I can get an idea of like how slow is it, and like what parts do I need to optimize? 208. That's really funny. I mean, it solves in microseconds, right? So potentially using Rayon or something would make it faster, right? But again, just at a high level, here's my part one is I'm going to go through all the locks. For each key, I'm going to, call the does it fit function, and I'm going to count all the ones that fit. And so this map is going to produce for each lock the number of keys that fit in it, and then I just have to sum them up, and that gives me my answer. Bada bing, bada boom. Easy, right? So what does the fit function do? Here I am more functional again today because it wasn't so hard. I'm like, ooh, I think a couple of these I originally had as for loops, and I was like, ooh, how much of this can I do functionally? So is this the most readable way? Probably not. But what do you do? How do you know if it fits? You basically just iterate and zip the zip the key with the lock. So you're comparing like this value to this value. You're zipping those two values. And so all you have to ask yourself is the key smaller than 6 minus the lock, right? Because the size is 6. And so you just have to say, is the key smaller than 6 minus the lock? Like how much is the key less than how much the pin in the lock at that position occupies? And if it is, if all of them are, then you return true, right? So that's all you're asking is you're really just doing this over all of the bits and or all of the pins and ridges in the keys. Okay. And that's it. That got me the answer. Relatively easy day. Again, I think I solved it. I don't know. This is a day. Well, we could look at the leaderboard. I suspect that everyone else solved this really quick. It only took me a couple minutes to solve it. And then I spent like a half an hour saying like, there's not even comments in here, right? So, and then I just was like, ooh, how many of these functions can I turn into functional style programming, right? And so I got most of that's where I kind of fixed. I think this one I wasn't doing the fold like we talked about in previous days, so I fixed that. And this one I was doing in a double for loop, right? Because you loop over the lines and then you loop over the enumerated characters. I fixed that. This one I actually did. I was like, oh, this one works easy as a functional because I'm basically just zipping these two and checking their values. And so this one was not too hard to do as functional. But that's my day. There's not much to it. It's not crazy. I'd love to see how you did it. Can you do it more concisely? I imagine you could. And if you can, I'd love to see how you did it. So it's actually, again, today was not a hard day at all. Thank you for not making it too tough. It's always nice to end on like a you can take a breath type thing and you didn't like rack your brain around it like I did for day 24. I had a lot of day 24 was crazy. So let's see. Can we find any people talking about day 25? All problems in under 250 milliseconds. That's really cool. Day 24 and 25 are basically 0. Yeah, you can solve them really fast. I could even optimize it further, I'm sure. Interesting. Let me see if I can't find... Maybe we just look at some of the solutions for day 25. Again, it's not a crazy day. Wow, look at how easy it is in Haskell. Key, locks, keys, length, key... LK locks keys compatible LK compatible schematic pool. Wait, where? I feel like I'm missing. Oh, okay. Yeah. You have to like build it still, right? I was like, that doesn't look like it's solving, and that looks like it's just. Okay. Again, these are not very tough, but you can see like the solution is actually not that hard, right? Is you just check if they're compatible, and then for each of the keys, like the Cartesian product of the keys, you just figure out what they are. Self-contained solution. I mean, I don't know if I'm going to find any magic in any of these. I don't suppose I will. I did take some liberty of just assuming that the locks and keys were the same length and height, which they ended up being, and so that made the problem kind of easy. Yeah, so just a double loop right here. You're literally just counting them up. And you're just checking each of them. I mean, nothing crazy about these, right? Finally, 50s. This was fun. Here's my code for part 1. I'll let you figure out part 2. I was angry at the chief historian. It was funny that he was just there all the time and he'd only gone for coffee. If you read the whole thing, that's what it says. Spoilers. Okay, we're going very functional here. Or sorry, very data structure oriented. Yeah, I kind of felt like, do you need to do all of this? Ooh, interesting. Partition map. Have I used that before? Sounds kind of familiar, but it never occurred to me to use this on the Fold 2. Like it's saying, like if you can kind of do a match on this, you don't even have to do this class. You can just do a match on like you create the value and maybe like the function returns whether it was a key or a lock. You do this partition map, and maybe that looks cleaner than this fold right here. We got a lot of time. I kind of wonder, should we try that? So we split n, and then we'll call dot part. Do we want to map twice? Does he map twice or just once? He does map twice. You map it to the type, and then you do a partition map. You could probably do the partition map. Let's just think of what it would look like. Where does this partition map come from? I don't have my key bindings set up. What is Copilot? Where's... Oh, did I just spell it wrong? Oh, it's part of itertools. Partition map. Quick fix. Import itertools. Either quick fix. Import. And then I don't have to do this fold. So I just need to enumerate these. Okay, that's cool. I like that even better. I mean, it's weird that it's using It's not weird that it's using itertools. I've actually found itertools really useful for some things. So, but that's even like more concise. Anyway, I'm gonna pull it back to what mine originally was, just for like sanity's sake. But when we do the recaps, we'll look at those. But that's a cool one to look at. Very cool. Let's see. Again, I don't imagine there's anything crazy about some of these. Let me close some of these. Janet. Yeah, not too. I mean, these are not crazy. It's they're all just doing the same things, right? So, is there anyone that did anything crazy? Mm, this might be a day. Is like how short can you get it? Okay, here's some Python dudes that do it in one line. For AB in import itertools combinations split print sum not any x y x equals y equals hash for x y in zip. What the? Okay, so this is a crazy. It's like exploiting the fact that a key always has the values at the bottom, and the lock has all the hashes at the top. This is some cool code, though, right? So basically, it's saying break up break up all of these into their own things, and then find the ones where they fit, right? But you might ask yourself, well, where does the why would you check a key against a key? And it's exploiting the fact that the keys all have these like figured out at the bottom. And so you could imagine a key where like maybe without these at the bottom, like if this wasn't here and you just had like this key and then you had another key that had these just these two rows, suddenly those keys would fit within each other. But because they all have one on the bottom, they won't fit, right? And so all you have to do is say, um, sum up. So you take all the combinations of all the things and basically sum up any of the cases where uh, x equals y is not x and y are a hash is not the case, right? So you're basically you're doing a comparison of each of the two. So like you're comparing this one with this one, and if you say if I ever find a hash in the same position as a hash right here, then I know I found a bad one and it doesn't work. And so because you can exploit the fact of like keys always having the hashes at the bottom and locks at the top, you could get a crazy one-liner like this. That is very cool. Very cool. Because of that exploit, I wonder if you could even make it at, I mean, you probably can't make it a one-liner like you could in Rust, but you could imagine doing the same thing is like use itertools to do a Cartesian. You basically just take these blocks and do a Cartesian product of them and just zip and say none of them can be equal to that thing. That's really cool. So that's something I'd like to do on this day for sure. Um, yeah, I think a lot of people may just say, oh, they did it in ASM. Cool. They really do all the days in ASM. This one is a very easy one to do in ASM because you basically, if you think about it, you're just like you're taking chunks of the input and you're comparing it to other chunks, right? And you can literally just compare bits. And so you have like, yeah, potentially like 2 loops, it looks like. Anyway, did they actually do... Oh, did they do it a different language each day? Okay, that's cool. Locks keys, keys that are map, locks that are filter, key and lock equals 0. Oh, that's interesting. If you convert the hashes to ones and the things to zeros. Is that it? Oh, you're just collecting all... You're collecting like a bitwise pair of all of them. And then so you have keys and locks that are basically just a long string. This is something that actually happens a lot. Like, the way to think about it is you can represent a 2D array in as a 1D array, where you're just like, the second row you jump past the first row type thing. And so it looks like that's what's happening. You get all the bytes and you fold 0. You just you shift 1 and OR it with whether it's a hash. And so you're slowly like building up bytes to get you to the end. And then you can just check each of the byte bits or whatever and say, if I AND them together, does it produce a 0? Right? You'd want to AND them because you'd want 1 with it and 1 without. And so if that produces 0, you include it in your count and you sum it up. Ooh, that's interesting. The new line might mess up the thing. Okay, interesting. Transpose. Oh, I mean, you are transposing. I was gonna say, like, how that's not a one-line solution. You're just transposing the values. Okay. Yeah, very cool. Ruby. I almost took a job that did all their stuff in Ruby. No part 2 because I still need to analyze day 24 part 2. Yeah, I don't know, part 2 day 24 really got me, which if you're watching these in order, you'll see. Okay, I don't know if there's much. I honestly don't think that there's anything crazy about this. So like, my imagine is people used this to like flex a little bit. So like me, I said, "Hey, can I do this in a really functional super way?" And I presume I could make it even more functional if I wanted to. Again, by like using partition map is an interesting thing over this fold versus this fold, because I'm only folding into 2 things. Um uh Anyway, you can definitely do this in a very functional, like, this would be a perfect one for like Haskell or whatever. So I imagine most people were just flexing on like, how short can I get it, or how optimized can I get it, or can I use some archaic language? I don't know, maybe that person did all of it in assembly. That is pro for some of these. Like my assembly courses, I don't think we did anything much more complicated than like, how do you represent a loop in assembly? Now, how do you represent like calling a function and adding to the stack and stuff like that? So doing some of this crazy stuff would be really interesting in assembly anyway. Anyway, there you go. There's day 25. That is the end of Advent to Code. We got all the way through it. I had a lot of fun. I always love these. life gets crazy through the holidays, and so I have this tension of like, should I solve it throughout the year? But I love to solve it, and so I'm glad I got to solve it. Um, I don't know if I'll keep doing it just because of family priorities and stuff like that. Um, but maybe I can work things out to figure out some way to get it all to work so I can solve them. I What I should say is I don't know if I'll keep solving it day to day. I maybe we'll take it at a slower pace next year. Anyway, let me know what you think. How do you solve it? Maybe you're not here yet, and maybe you're not seeing this until way into the future, and that's okay too. I hope just what you get out of all of this is um, sometimes it's not easy to solve a problem, and it's okay to stew over it. There were several days where I didn't know the answer immediately. I had to think about it. I was like, okay, I'm going to go do some chores or go do something else, or I'm going to, stay up late into the night to try and figure it out, or I'm going to wait till the next morning. There were a couple times where I was like a couple days off because I was sick too. Don't feel pressure to solve it the very first day, obviously, unless you're going for the leaderboard. Um, but just have fun doing this stuff and learning and growing. We learned new algorithms, at least I did learn new algorithms this year that I had not heard of before. And that's what makes Advent of Code cool is I feel like it helps remind me of things that I've learned in the past. It helps bring up new things that I've never learned before. All of this comes together of like just making it really fun, right? And so I'm not done. If you looked, I think I showed this last year or last video. I actually haven't solved all the problems. We need to go and finish the int code ones. I have two of those that I need to finish. I'm probably I really had fun building the int code computer. Those 2 days I'm probably just going to go with can I just solve it as can I just solve these because the next one is like a networking one that I looked at and it felt like oh it doesn't really change the int code much. It's just managing the inputs and outputs of it. So anyway, we'll see what the rest of the days look like. But I have a couple years that are unsolved, and a lot of these I've solved, but I just solved them on my own, right? In my own free time. I would like to keep going over these Advent to Code solutions and seeing if we can't map them to some kind of data structure or some kind of algorithm. And just so, like, because puzzling is all about solving these puzzles, is just about knowing or learning what data structures to use when and what algorithms to use when. And so maybe going back through previous years might help with that. Obviously, I've done all of the days of 2023, but my plan is this is all a long-winded way of saying my plan is I'm going to do some recaps of day 2024. I've kept some notes of some days that were really interesting and days that we went and looked or I looked as well later and found even better solutions than what I had. So I'll highlight those and show you some cool things and maybe some more like understanding of the complexity and how to solve it. Like for example, day 24, the previous day, I definitely feel like I want to go back there and solve it in a more rigorous way. Those type of things, I'd like to go back and solve those, and then just keep working on some more of these Advent to codes. Let's finish the int code, maybe just do some solves, and then let's try and finish the rest of these days. See if we can't get to. It's been 10 years, right? So 500 stars on the through these videos, right? So that's another 400 some odd videos. Maybe we'll start with the ones I haven't done, and then we'll look at some of these ones that I have done. I know some years I was doing them in Go, and so maybe we can work on those ones as well too in Rust or some other language, right? I think 2023 I did half of them in like Haskell until I was like, I just don't think I know enough Haskell to solve some of these. So that's my plan. I would love your feedback though. Send me the things that you'd like me to talk about. Do you have a specific day or year that you found really interesting that you'd like me to solve? Fair chances are I don't remember how I solved half of these. So if you say, oh, Josh, one of my favorite days was 2016 day 22 grid computing. I have solved it at one point, but it was so long ago, I probably do not remember how I solved it. There's very few days that would be notable that I would actually remember. In fact, even 2024, man, I tell you what, growing old, you lose you lose your memory, right? If you ask me like what day 7 was, it would take me a while to figure it out, right? And like I honestly just even looking at these examples do not remember what was going on. Oh, this was the day when you were like trying to figure out can you add or multiply, and then it add the concatenation operator. So instead of being like 15 plus 6, you could also do 15 concat 6 to get 156. Okay. There's interesting days. Oh, and this is definitely a uh, caching one, right? Memoization, dynamic programming with memoization. Anyway, let's go back. I'd love your feedback and your input, and we'll keep working on these Adventa codes until we've got them all done. So that's it. Bye, everybody.